February 1943 through mid-1944. A New Perspective. 20. February 1943. In the dry, dusty fields north of Kasserine Pass, the morning was just breaking. A small, easily overlooked thing, a voice on a microphone, a sliver of clarity on a radio band, was about to change the shape of battle. That morning, the way American tanks coordinated was not merely a tactical trick. It was a new rule. More powerful than the tank's steel was an invisible thread, radio waves, that bound crews to one another. German tankers first sensed that transformation when all they heard through their F-Fugue receivers was scratch and static, while Shermans ahead of them moved as if conducted by an unseen hand. German platoon leaders clung to old habits, visual signals, pre-planned maneuvers, and rigid hierarchy. But one thing had changed. Every American medium tank was now a transmitting node. That changed the dynamics of combat. This change was the result of a long engineering story. From Detroit assembly lines to Chicago mounting floors, small FM circuits redefined battlefield communications on an industrial scale. Frequency modulation, once limited to civilian broadcasting and experiments, became a military standard. Stable crystal oscillators, higher output transmitters, and vehicle-grade ruggedization made it practical. The sets that went into each Sherman, known to technicians as the SCR 508 family, combined transmitter, dual receivers, and an intercom. A system that let the crew not only listen, but speak and monitor multiple nets at once. On the battlefield, that advantage translated directly into decision speed. When one tank spotted the enemy, it didn't simply swing its turret. It spoke immediately on the company net, alerted the artillery net, and called supporting armor. This wasn't a loosely choreographed dance, but a real-time information loop producing a flowing situational picture. With 25 watts and FM clarity, that flow stayed coherent for kilometers despite engine noise and bad weather. At Kasserine Pass, the lesson showed itself. Tactically, the Germans could claim victory, but the strategic and technological revelation came from the Americans. When communication is dependable, dispersed elements operate like a single organism. Crewmen who had previously acted independently became part of a battalion-level awareness through their radios. German signals units intercepted transmissions and noted the clarity and range, but dismissed it as superior training rather than recognizing a systemic technological edge. In the Italian campaign, when mountain valleys and multipath effects would have ruined AM systems, FM held up. American engineers realized this was not just an optional component, but a design philosophy: equip every vehicle. When Shermans on the Normandy beaches coordinated with naval fire support, they integrated into a synchronized system of effects that sharpened assault timing. There were problems, of course. Tank radios and infantry radios used different frequency bands, creating deadly communication gaps in Bocage country, where a Panzerfaust-armed infantryman could close on a tank without nearby friendly infantry being able to warn it. Practical field fixes, wiring EE-8 field telephones into tank exteriors, for instance, bridged the gap quickly and showed that technological superiority needed adaptability on the ground. Behind the scenes, the factories were humming. Capacitors, resistors, crystals, thousands of parts. Quality control mattered. Frequency drift, vibration, and temperature extremes all required engineering solutions. This technical achievement was not merely a radio set. It was a supply chain, an engineering practice, and a training program. Only such industrial momentum could produce thousands of reliable sets in wartime. On the battlefield, the psychological effect was profound. American crews had the reassurance of never being truly alone. Every report, every call, every backup request created a safety net. German crews experienced the opposite: isolation. Isolation led to tactical errors, delayed reactions, and sometimes the collapse of whole platoons when a command vehicle was destroyed. Guderian's doctrine had long recognized radio's importance, but production limits and distribution failures left his doctrine unfulfilled. When Operation Cobra in 1944 saw hundreds of tanks operate through radio nets, the results were measurable: rapid concentration of force, quick artillery response, and nimble ad hoc battle groups. Modern observers can see in those operations the earliest examples of network-centric warfare, where tempo and information flow, rather than platform superiority alone, decide outcomes. German intelligence, seeing the coordination, labeled it good training and missed the technological root cause, a classic failure to grasp why an effect occurred. Before Part 1 ends, one fact is clear: war had ceased to be solely about steel and shells. An invisible layer, control of the electromagnetic spectrum, power management, and signal discipline, had become a central axis of combat. And that axis ran on American industrial mobilization and engineering ingenuity. Mid-1944 through the closing operations of 1945, the story of a network. By mid-1944, Normandy's fields and hedgerows exposed German tank doctrine in new ways. Shermans, imperfect on paper compared to Panthers or Tigers, possessed a decisive quality. Their crews did not have to see one another to fight together. They heard one another. A company-level radio net reduced command latency. What once took a quarter hour could now be achieved in minutes. Integration of radio and intercom changed crew workflows. Commander, driver, gunner, and loader shared a common picture through internal communications. A gunner no longer acted on line of sight alone. He might hear over the net, "Left hull, infantry contact, 600 meters." Those inputs shaped split-second decisions and transformed single vehicles into coordinated group actors. German attempts to counter this advantage were inconsistent. Some units improvised, adding receivers, prioritizing transceivers in command vehicles, enforcing radio discipline, but chronic production bottlenecks and weak electrical suppression undermined their efforts. Many German crews still relied on prearranged plans and visual signals, which failed in fluid modern engagements. On the Eastern Front, the situation differed again. T-34s were often delivered without radios. Soviet doctrine emphasized mass and prearranged coordination. In some cases, this yielded overwhelming results, but in terms of tactical coordination, Soviet units were relatively disadvantaged. Lend-Lease supplied some radios, but penetration remained partial through the end of the war. Another technical dimension was interception and signature. American FM clarity sometimes made intercepted transmissions less exploitable. German listeners could tell that American units were well coordinated, but not always extract precise targeting or fire control data. The paradox was that clearer signals could reduce the enemy's ability to turn intercepts into actionable intelligence if the nets were disciplined and short. Logistics and maintenance mattered too. SCR 508 sets needed stable power. Dynamotors, batteries, and rugged wiring harnesses and vehicle electrical systems were upgraded and standardized to prevent radio interference. EMI suppression, spark plug shielding, and proper grounding became small but critical practices that determined communications performance under combat conditions. As Allied forces penetrated Germany in 1945, the cumulative effect of communications superiority became strategic. Rapid exploitation of tactical opportunities, capture of an intact bridge, a collapsed flank, depended on immediate reporting, rapid allocation of follow-on forces, and combined arms coordination. Remagen is illustrative. Once the Ludendorff Bridge was seized, radio traffic moved reinforcements and created a defended bridgehead within hours. German reliance on wired communications and fragmented wireless capacity could not match that tempo. Post-war technical assessments confirmed battlefield observations. Intelligence teams cataloged equipment and measured capability. German sets had lower transmitter power, AM vulnerability to interference, fewer transceivers per formation, and inconsistent intercom adoption. American reports emphasized doctrine as much as hardware. Equipping every tank and training crews in radio discipline mattered as much as the radios themselves. That lesson shaped post-war militaries. The Bundeswehr and NATO prioritized comprehensive communication suites in armored vehicles. Doctrine evolved to view information networks as force multipliers. The idea that connectivity could compensate for platform disadvantages became axiom. In later coalition operations, this lineage is visible: secure digital command nets, integrated battlefield management, concepts that trace back to the FM radio revolution of the 1940s. Yet technology is not invincible. Radios can fail from battle damage, jamming, or human error. Units must train to fight when communications degrade. Enemies can adapt. Jamming, deception, or attacking supply lines and antennaed command vehicles are practical counters. World War II only witnessed early forms of electronic countermeasures. Later conflicts would broaden that domain. The human factor remained decisive. Crews who best exploited radios, practicing brevity, signal discipline, and net etiquette, converted technical capability into combat power. The finest radio in the world is useless if crews chatter unsecured messages that reveal positions or delay essential reports. Beyond the technical and tactical is the intangible: morale. Soldiers who feel connected to command and support act with greater confidence. Isolation breeds hesitation and fragmentation. In memoirs and after-action accounts, a clear call from a forward observer or an immediate artillery correction often appears as a turning point. Morale is hard to quantify, but clarity of communication converts doubt into decisive action. When the guns fell silent and armies examined the war, engineers and strategists distilled lessons. Universal radios in each fighting vehicle moved from logistical headache to doctrinal cornerstone. The war that began as a contest of steel and numbers became one in which mastery of the electromagnetic spectrum mattered sometimes more than armor or gun caliber. The Sherman is, in this light, less a single-platform triumph and more an exemplar of systemic achievement. Mass production married to a unifying, networked capability. Its advantage lay in ubiquity and in the way it rewired tactical command and control. Across Tunisia, Italy, France, and Germany, the ability to share what you saw instantly, reliably, and securely often decided the battle before shells finished their arcs. Commanders in the post-war years would teach a simple principle. A force's effectiveness is not measured solely by weapons, but by its ability to share vision. The radio revolution that matured during World War II planted that seed. From Tunisia to the Rhine, from hedgerow to hilltop, the future of networked warfare arrived on a dusty morning when 5 Shermans converged, spoke in invisible tongues, and acted as one.